Okay, hello guys. Well, I'm going to share my screen. Let me 1 second. Let me know it's showing. Great. Well, hello, my name is Valentin, and I'm here today to tell you about adaptive layouts. The last version of Material Design 3, includes a new guidance about it, so we will explore it together. Well, adaptive layouts react to input from users, devices, and screen elements. Material describes how to design for variable screen sizes from phones and tablets, and also desktop, but we are not going to put the focus on desktop today. This information is going to help us build apps that scale smoothly and adapt to meet the needs of multi-device users' flows. Well, let's review some of the concepts. Breakpoints. Breakpoints define the screen size at which a layout will adapt to best fit content. A breakpoint range informs how a screen adjusts to fit its size and orientation. When using window sizes, an app can alter the number of layout columns to be used inside a grid container as needed. I have an example app that use the window size classes, the compact, the medium, and expanded one. So later I'm going to show you how to work with that. Then we have the responsive layout grid. The responsive column grid is made up of columns, gutters, and margins, providing a convenient layout structure for elements within the body region. Components will align with the column grid to create a logical and consistent layout experience across screen sizes and orientations. As the size of the body region grows or shrinks, the number of grids columns change in response. So we are going to start with the design for large screens. When we work with the large screens, we can consider that we have three large regions. The first one is the navigation one, the app bar, and the body. The navigation region holds navigation components and elements such as the navigation drawer or navigation rail. It helps users navigate between destinations in an app or to access important actions. The navigation region maintains a consistent width of 256 dps when expanded and 72 dp when collapsed. When using a navigation drawer, the body can react to size changes. At the left, we can see the navigation drawer, and at the right, this is an example of the navigation rail. It changed a bit the elements and well, on the arrangement there. The body region is used for displaying most of the content in an app. It typically contains components such as lists, cards, text, and images. So how we can arrange these types of components? Well, there is a method called containment. So containment is a method for connecting related elements that share a context. It's a form of grouping that visually relates elements in a view and establishes boundaries to distinguish unrelated elements. So we have two types. The implicit containment is a method of grouping content or elements that may not appear to have edges, but manage to impart an implied boundary or container. Explicit containment methods show container boundaries and clarify that an item can be tapped. Also, explicit containment methods includes adding an outline or elevation level to a group of related elements. Can also be used to emphasize something. Component adaptations describe changes in visual presentation, padding, size, layout, or alignment, or switching out one component for a different one to better suit the device size and use case. In this case, for example, when we change from a mobile layout to a tablet one. So the visual presentation. This type of adaptation affects the scale and placement of content and object on screen, as well as the relationship to each other. Component swapping. As a layout changes across screen sizes, components with similar functions can also be exchanged. This makes it possible to adjust layout for large scale changes. Component can switch types, for example. A full screen dialog, this image number 1, on mobile can be exchanged with a basic dialog on larger screens. This component change maintains the function of the dialog while also making use of the screen space in a way that preserves the user context by revealing underlying content. Responsive patterns. The arrangement of components in a layout can also adjust with changing in screen sizes. These adaptations occur either by repositioning the component or revealing information based on available screen space. Parts of the UI that are hidden or smaller screens can be revealed when adapting for a larger screen. On a mobile device, the navigation drawer is collapsed. On a tablet, the navigation drawer is open to reveal more actions and features. A UI and its components can reposition to make use of additional space on a larger screen. Repositioning is also a way to accommodate ergonomic and input needs to change across device sizes. Elements in a single column format can reflow to fill the content area on a larger screen. So now we are going to talk about foldable devices. Foldables use flexible screens that can fold and unfold to expand the available screen space as needed. One of the differences between tablets, phones, and foldables is the center hinge. The center of the folding screen has a tactile difference due to the device hinge that enables folding. We have to avoid placing important information and actions along the center of an unfolded screen. In this case, we are showing an example of a center hinge in landscape and in portrait mode. Well, we have two types of hinges. The first one, simply hinges are barely visible, although some users may feel a tactile difference on the screen surface. All type of foldable models use this type of hinge. The other one, on devices with a physical hinge, for example, this is the Microsoft Surface Duo. Designing the screen as two distinct layouts allows a composition to work in a better way. So we are going to have like two different, it's like having two different screens, but well, we are going just to use them as one. Postures are the screen configuration that foldable devices can take on, offering several different layout content for an app. So now we are going to explore these postures. The first one, folded. The folded posture has a front screen that uses similar proportions to a typical mobile phone, known as the outer display. Unfolded. An unfolded posture refers to the open screen, which is typically double the size of a front screen or the size of a small tablet. An unfolded posture can have landscape and portrait orientations. In an unfolded posture, the device folding hinge can be noticeable on some models. In the unique case of I already mentioned the Microsoft Surface Duo, the hinge divides the screen physically into. Unfold portrait. Portrait mode applies when the longer screen edge is vertical and the shorter edge is horizontal. Book mode. Book mode is the portrait in which the device is half open with the hinge vertically. It's the same way as when we are reading a book. Tabletop. Well, this is the new posture, let's say, that was introduced by Google. Tabletop describes a screen posture in which one half of the folding screen sits perpendicular to the other half. The tabletop posture resembles it's like having a laptop. One part of the screen is flat, while the other half sits upright at a roughly 90-degree angle. Well, things to consider when we are working with foldables. Reachability. When the screen is unfolded, the top 25% of the screen is likely out of reach for most users, unless the grip is adjusted. To accommodate device and hand sizes, we have to limit the amount of interactions that are placed in the upper 25% of the screen. Additionally, we have to avoid placing essential interactive elements too close to the bottom edge of the screen, because some users, particularly those with larger hands, might struggle to reach this area of the screen. So in the first area, users can reach this area by extending their fingers, which make it slightly inconvenient for many to reach. The area 2, user can reach this area comfortably. This is the common when we are going to place most of our elements to interact. Area number 3, reach this area is challenging when holding the device because of what we say about the larger hands. Dividing the screen. We have to avoid placing key actions such as dialogues along the center hinge because the interaction of visibility will be affected. So when we are going to show a dialogue, we have to be sure that if we are in a foldable device, we have to show it on the left or the right, not in the center, because if we are using, for example, the Microsoft Surface Duo, it's going to be affected by the physical hinge. In a landscape orientation, we had to place primary navigation components on the vertical edge of the screen, as shown in the picture number 1, and separate content and elements into 2 columns. Portrait. Use 1 column for portrait layouts. Horizontal space is limited in portrait mode, so leaving little room to meaningfully implement 2 columns. But in some cases, you can use 2 columns for an unfolded portrait layout if content can fit within the narrow view without excessive distortion. When designing for foldable devices, there are 2 primary methods for managing the expanding and contracting screen space. When a screen space is expanded because the device is unfolded, the large canvas can be used for either extending an existing view or adding a separate additional view. Extending a window. This can mean adding a second column of content or rearranging the content areas. Some example could be adding a second column of content or creating a more complex layout of photos. Combining windows. Consider taking multiple screens for one flow and presenting them in a single view on a foldable device. Some example, an inbox view alongside a single message view, text message list view alongside a single conversational view. Well, and how about scrolling? Depending on how an app extends or combines windows, the scroll behavior of the folded design may change in the unfoldable design. For example, if you expand a window, you can decide whether the whole screen will scroll together or each side, each column in this case, scrolls independently. If you choose to combine the windows, each side of the screen will operate as independently scroll areas. Well, so now we talk about all this kind of concept. The idea now is just I made a simple app for foldable devices. So the idea is to show you how it works. I'm going to stop sharing the screen, and I'm going to share the IDE. 1 second. Okay. So here I have my app. It's just a simple app. You will see that I don't have like a data layer or some other layer for the business logic. So it's just the UI. So something that we talked about was the window size classes. So for that, we have this, I declare an enum that we have like the compact size of the screen, the medium, and the expanded size, just following the table that I show you in the presentation. For that, I have the screen classifier. The screen classifier is, well, it's a classifier that says, well, when the foldable device is fully open, like it's in a flat mode, or if I have the foldable device in a book mode or in a tabletop mode. So I have like these 4 types. One, the book mode and the tabletop are inside the half open because, well, they are in that is like the parent mode. Then we have the screen info. The screen information is, for example, I'm just following the table. If I know that, for example, the width needs to be compact, so I just compare it with the size of the screen, and I set that device as a compact device. Or if the device suits to be medium, I just treat it as a medium device. This can be done comparing the height and the width. Most of the device, if you only compare with the width, it's just right. You don't need just to do it with the height also. So then, if we see the Hello app here, so for trying to know in which type of device I'm working, I need just to use the screen classifier. The one that says, well, if I'm in a fully open device, or if I'm in a half open device, in a book mode or in a tabletop mode. How we can, for example, measure the screen or get that information from the screen? Well, it's just, for example, in your composable, you can have a device posture that is here. This device posture is going just to, it's a flow that starts like sending you the posture that the device is at that moment. This posture is going to trigger the composable to be to a recomposition, just to redraw, let's say. So I create here a hello info screen. This hello info screen is just a composable that has a text that says the state of the foldable device and the dimensions. So here I have the app running. So I'm going to, now it's, as you can see, it's in fully open. But for example, if I go here into the virtual sensors, here I can change the way the emulator is, if the emulator is going to be in book mode or tabletop. So I'm going just to change that. I'm going to fold the device, and you see that now the device is in book mode because I'm just folding. I'm folding the foldable device. So the view just listen to that and just update the UI. I'm going just to put it again in full open. Now let's see if we can put it in tabletop. I'm going just to fold it again, and you will see that now the device is in tabletop mode because the hinge is horizontal. In the other case, the hinge was in a vertical way, so it's in that case is in a book mode. So now I have a UI to show you. I'm going to comment this. I create like a grid and also just a simple composable that shows an image. So I'm going to run it again. So now you can see as the view is in full mode, I can just place the entire grid. But for example, if I'm folding the device, you see that it changed the arrangement of the composable. For example, now I have the grid. The grid is at the left of the screen, and here I have, for example, the first image. I can just change it, typing the different options that I have at the left, and this is going to change the image at the right. So now, if I, for example, go into a flat mode, that is going to go to the selected image. But then I can go back and I go to the screen. Then I want to show you one second here. How I know, for example, if I'm in a book mode or if I'm in a tabletop of a fully open screen. That is because, for example, every time that there is a change in the layout, I'm getting a folding feature. This folding feature has like 4 properties. The first one represents the current posture state of the foldable device, such as the state is flat or the state is half open. Then I have the occlusion type that calculates the occlusion mode to determine if a folding feature occludes a part of the window. This flag is useful for determining if UI elements need to be moved around so that the user can access them. This occlusion type is the hinge that we talk about. Is separating determining the folding feature should split the window into multiple physical areas that user will view as logically separated. And the orientation returns horizontal if the folding feature width is greater than the height, or vertical otherwise. So if for example, to know if I'm in book mode, I need to check if the state is half open and if the rotation is vertical. Because if the rotation is vertical, it means that the hinge is is vertical. So that means that I'm in book mode. Tabletop mode. Just to know if I'm in a tabletop mode, sorry. I also need to check if the device is half open, and also if the rotation is horizontal. So if the rotation is horizontal, I know that the hinge is also horizontal, so I'm in a tabletop mode. Then, if we are not getting that we have a folding feature, so probably it's a tablet, we are just going to check if we are in a fully open device. So then we can check if this device is a phone, if the device is a tablet, and check the size of this device depending on on the information that we are getting. And yeah, and that's all. I don't know if anyone has any question about this.
Cool. So the idea now is that if anyone has any questions, you can just enter them in the Q&A box. You should see that, I guess, in the menu below the screen. So yeah, we're just going to give a couple of minutes to people, to those who want to ask questions. So feel free to do it, and we'll go through them in a couple of minutes. Okay, so we have a couple of questions here. Let me just read the first one. Can devices that physically split the screen in two be supported?
Yes, we can support this kind of devices. So the idea is there is an emulator from Microsoft that allow us to have a device that has the hinge that blocks the layout.
Okay. Then we have another question. Where is this code? I would like to check it out later. I think we can make a repo for people to check it out, right? And send it over on an email. We have everyone's emails. So yeah, we can get it over to you. Just give us maybe a day or two and we'll send it over and you can check it out. And another question that we have is, how can we test it?
Okay, so here probably I can share with you guys this part. Probably had to stop sharing, sorry. And I'm going to, I have an emulator running that, 1 second here. So I have an emulator already running that it just emulates Microsoft Surface Duo. As you can see, there is like a black rectangle in the middle that simulates the hinge that, well, it's just blocking some of the UI. So if you want just to test a foldable device with this type of hinge, you can just download this emulator from the Microsoft page, for the website, sorry. Probably I can add that link to the code.
Okay, and well, it seems that this is the last question that we have. Can we navigate when using adaptive layouts?
Yes, it's the same as a typical app. We can just navigate. They are just composables. So there's no web. If you are using adaptive layouts, that is not going to affect the navigation graph that you already have in your application.
Perfect. Okay. Any other questions that anyone may have? Well, this is the time to send them over. If no one does have any questions right now, that's okay too. We'll wrap things up for now, but we'll make sure to send you the recording of the session via email, probably in a day or two. Same with the person who asked about the code. We'll get you that as well so that you can review it. And yeah, if you have any other questions that come up later, you can always reach out to us and we'll be happy to go through them. Thank you everyone for joining. I hope this was an insightful topic for you, and we hope to see you in our next session. So yeah, have a good day, everyone. Bye-bye.
Bye-bye.